Hello. For this video, I want to make a reference to talk about some electrical quantities before I do, I make other references to other units in circuits 1, because I hope to make this video as an introduction to a review for circuits 1, which I already took, and I think I did pretty well in. So for direct current, which is a current that pretty much flows in one direction, either constantly or impulses. The quantities are current, symbolized by capital I, and what this means is it is the amount of electrons passing a given point. So you have, let's see, some conductor. Oh, that is really poorly drawn. A conductor tube, and put this in, and you have a bunch of electrons passing through. So I'm going to draw electrons as holes, which is pretty awful actually. I'm going to regret this, but this is just for reference. Actually, no, I have time to fix this. So a bunch of electrons flowing through, and if you sit there and count it at a given point, and this is pretty much what current is. If you, let's say, have a person watch it at this given point, the amount of electrons that passes per, typically it's in seconds, per seconds, is the current. And it can also be denoted by dq dt, or the change in charge with respect to time. And the units for current is in amperes. Next, there is voltage. So voltage is pretty much electrical pressure. Voltage actually is kind of difficult to explain, and I will have some links in the comments, or not in the comments, in the description to explain it, or to, I guess, try to explain it. But there's a little bit, it took me a while to really understand voltage, because you need to know that it's with respect to two things, right? So, and that's, I guess that's all I'll say for this reference video. And it can also be written as the change in work with respect to time. Well, no, this is not with respect to time. My apologies. This is with respect to charge. Change in work with respect to charge. So, and work is in joules and charge is in coulombs. And so, which basically is 1 volt, or joules over coulombs is a volt, right? So joules over coulombs. Sorry that this is so poorly drawn, but I'm using MS Paint, so everything's kind of scuffed. And lastly, is resistance, right? Resistance is pretty much the opposition of flow. I'll talk a little bit more about this later on, but resistance, it's typically a constant, and its units is, well, in ohms, and you write ohms as the omega, the Greek letter omega, right? Or, you know, if you're me, it's an upside down horseshoe. Either way. But yeah, and also right here to the right is pretty much an analogy of what these things are. So this is, if you can't recognize, it's a water tank, and the water level is the voltage, right? And so which is pretty much, yeah, it's the voltage. I don't want to talk about anything more. And right here is the tap, which basically restricts the flow of electrons, or flow of water, which is, I guess, electrons, and the stream is the electrons that are coming out. And this I shamelessly just copy from Forrest Mims. notebooks. Yep, there it is. Alright, and I think that is all for this reference video.